Good morning. Thank you for joining us and welcome to our weekly e-learning session. My name is Dwayne Henderson, a member of Cree Lighting's training and education team and host of our e-learning series. For those watching live, happy Friday. Quickly about the session, they will be 15 minutes in duration. Our presenters will be available for Q&A at the end of the presentation. Although the attendees are muted, we do ask you guys to use either the chat or Q&A box to ask questions. Please feel free to type those in during the presentations, and again, we'll go back and answer those at the end. Today we're going to learn about the functionality of a DLC qualified network lighting control system. Walk us through that. I'd like to welcome back John Vollers. Good morning, John.
Good morning, Dwayne.
Hey, John, before we get started, can you quickly remind the audience about your role in the business?
Sure. My name's Jonathan Vollers. I'm the technical manager here at Cree Lighting, and my main focus is on lighting qualification, including Energy Star DLC, as well as our accredited photometry lab.
Perfect. All right, let's get started.
All right. Today, as Dwayne mentioned, we're going to talk about what is a DLC qualified network lighting control system and kind of what does that entail, but also a little bit about why it's important or why do we care about it. So kind of the why we're going to get into first is just showing that, you know, the systems like Odyssey and SmartCast that we offer, as well as some of our partner systems, you know, wireless is kind of winning. The solutions seem to be really most, the lowest installed cost, has the most increased flexibility. The interoperability among manufacturers has actually increased quite a bit. And just understanding, you know, with more deployed systems out there, there's a lot of improved wireless architecture and performance, meaning, you know, designing for the space, understanding how wireless will work in that space and being very effective. But in the end, the value has just increased over the price that it costs to actually implement. So these are really important. And DLC and its network lighting control system does help drive a lot of this. They define it as a network lighting control system is defined as the combination of sensors, network interfaces, and controllers that affect lighting changes in luminaires, retrofit kits, or lamps. So that's a pretty good encompassing effort around what we're going to talk about today and what system functionality we expect. Oops, sorry. So the DLC has created technical requirements, and currently just released in June was version 5. Most everything that is out there right now is listed as under the version 4, which was kind of in effect for the last year. But the way it's set up is the same. There's required capabilities and reported capabilities. Those two portions. Required means that those list of capabilities have to be deployable on every system that gets listed on the NLC QPL. And when I say QPL, that's a qualified products list. There's some definitions down on the right if you get lost. But those required capabilities have to be deployable. The reported ones are nice to haves, are capabilities that are not required, but they do exist in a lot of the systems that are out there. And the DLC does report on those and gives detail on some of the different capabilities that a system might offer. So it helps to select the system that you might need or your application needs. Even though the required is a smaller subset, you might need one of those reported features. And we'll talk more specifically about what those are as we move forward. The other kind of differentiators are there's interior systems and exterior systems. They have two different needs. The application requires some different things. So they have slightly different required capabilities and reported capabilities. Now, all these systems are required to have a minimum warranty of 5 years. So that's super important as well. So looking at interior first, we're going to look at the required items in version 5 of the technical requirements. Obviously, networking of luminaire and devices, that's, basically that's part of the definition. Your sensors are talking to your luminaires and dimmers, and so forth. Everything's connected, and being able to provide a level of functionality beyond singular devices. The bread and butter, one of the bread and butter functionalities is occupancy sensing. Obviously, that's a huge energy savings. Having, not turning on lights or having them dim during vacant periods, super important in achieving a good lighting control. Daylight harvesting. You can see not so much in the center picture here, but maybe along these walls on either side, we're able to dim our electric light due to the amount of daylight available, and that's really important and can provide a lot of savings. High-end trim. High-end trim is kind of if you think of most troffers in this office environment that we're showing here, might come in 4,000 lumens or 5,000 lumens, something along those lines. You might not need all that light initially to actually achieve your task light luminance. Maybe we have really good task lighting under the cabinet here by this nice young lady. So you can actually bring that down at 95% of full power or 90% of full power and still achieve all the lumen levels that you want, but then you're still saving energy, you're increasing your life of your product as well, your luminaire. And then one of the other key items is zoning. Zoning is grouping. Obviously, the area, this office area we're showing here might be one big zone, or maybe it's in two different zones. If you had a conference room or an individual office, you want those dimmers and sensors to work with just that group and not anywhere else. In other words, you get some very odd functionality going on if a sensor in another room is going off and is lighting something in another room. So having those groups, having those zones really provides a lot of the customer satisfaction as well as enough granularity in understanding how your system will work within a space. And kind of part and partial to that is the individual addressability, meaning that each device is addressable, meaning as part of the system, it is, a sensor or a luminaire or a dimmer or any other device within the system is identified and is separate, and then therefore you understand where it is, what group it's in, what what occupancy setting it has, what daylight harvest setting it has, things of that nature. So you can understand the controllability of that system. Allows a lot more flexibility. Then continuous dimming. Continuous dimming is really seamless dimming, allowing for a good customer experience. There's not that herky-jerky feeling of like a step dim where you go from 100% to 50% right away. It's not very satisfying. And certainly in this environment where you have maybe daylight working, you're slowly changing that electric light to adjust with how much daylight is being provided. If it were stepping and jumping, it wouldn't be very satisfying. It wouldn't provide a lot of the energy savings that you would hope. So that's important. And then new this year in version 5, and it was not required in version 4, is a cybersecurity certificate. This is really a third party, like a UL or a CSA, an outside party, coming in and auditing and really getting an understanding of what SmartCast and Odyssey and Synapse and all our partners do for cybersecurity. We already have cybersecurity baked in, but it's kind of giving that audit feel to how well we're doing our cybersecurity and providing a certification on top of what we're doing. And that provides a level of confidence that these version 5 systems and beyond will be safe as possible against cybersecurity threats. And probably one of the other big, really important features that are in the required set is energy monitoring. Energy monitoring is something very important to both the utility, but also the consumer. Being able to, change your functionality, change your system, have flexibility is great. But if you don't really know how much energy you're saving, you believe you're saving energy, but if you're not monitoring it, you're really not getting that knowledge. So you can adjust your systems and do better and actually try different things and see if you can save more energy as an office manager or a facilities manager. But then also you can prove to your utility, who gave you maybe a rebate or maybe is giving you a continuous rebate on how much energy you're saving, how much energy you really are saving, and it's got real data behind it, not just theory. So that's super important. I will note that room-based systems, so something that's just isolated to a room and is not like a floor or building system, uh, is exempt from the energy monitoring. So now we get into the reported items, the nice to haves. So these are defined as, there's controls persistence. Which really just means that as a gateway or whatever control system is controlling a group or an individual luminaire, that connection is severed. Whatever the last settings for daylight, occupancy, and so forth were given to that luminaire or group still function. So if the controller's lost or the Wi-Fi goes down, the system itself continues to work as it was last requested to work. So that's important because obviously that does happen. Scheduling, whether you have maybe a 5-day work week and you have a different type of occupancy on the weekends, you want to add some functionality there. We want to report out that capability is available to do that type of scheduling. Device monitoring and remote diagnostics, that's another way of saying, hey, my luminaire is failing or something's wrong with this sensor, and being able to tell you what group it's in, or maybe doing some diagnostics as to why it's failing. So those type of features are in some systems and not in others. The type of user interface, you could be handheld control device, it could be a laptop, it could be a central control unit or server, or it could be a graphical user interface or GUI on your phone, a little app, and you can do some functionality with that. So what type of user interface is available? And then luminaire level lighting controls, or LLCs. That's SmartCast is, those luminaires have sensors embedded in them. So that's luminaire level lighting control. And what that does is it provides a sensor at every light point, and therefore provides a lot more flexibility and some different features that can be done. So they want to know if that's available for your system or not. Personal control, if this young lady, again, over on the left there of this picture, wants some functionality and she give her personal control of her space and maybe the luminaires above her, that's personal control. So that might be a feature of your system. And then plug load control, which is kind of important in California in certain situations, but basically is a device on a plug, wall plug, that any load on that can be shut off or during a demand response request. So it just provides some functionality that isn't related to necessarily the luminaires, but could be part of that system. Whether the system interfaces with emergency lighting, whether it maybe has color changing or color tuning, and then how easy is it to implement? Like, what's the setup like? DLC wants to provide some data to its customers and people that use the QPL on how easy is it to install and commission. And then scene control is one of the last reported items where, if you have an entryway or you have more dynamic lighting and you want to set some different scenes for different times of the day or maybe for different events, whether that scene control type of option is available in the system. And again, for energy monitoring, only room-based systems now can report that they have energy monitoring. It wasn't required as it was for all the other systems. Then the last two are load shedding and demand response, whether they interface with those type of systems and really through the external systems integration, meaning, do you talk to a building management system? Can you interface? Can you provide data to that system? Can you take commands from that system? So those are other things that are reported as well. And here we're going to just quick talk about the external systems. There's only a couple differences that are identified here in the required area. They've added traffic sensing as part of occupancy sensing, because obviously some outdoor systems really don't look for people necessarily, but they look for vehicles. So that's kind of a feature that they wanted to add or define. And then also scheduling is now required, and that's mainly because astronomical scheduling with sunrise, sunset, You have certain times of the year where you're going to have a shorter night schedule, and you also want to be able to, you know, during hours of operation, you might be at 100% power, but then go down to like 50% power at some time during the evening, with only occupancy popping it up to 100% or traffic sensing. So those are features that are more critical in an exterior system. So scheduling is part of the required set. And then on the reported side, all the reported items are the same as interior except for two things: personal control and plug load control. Obviously, you really don't have exterior systems with personal control, or there's really plug load is not really kind of applicable to that type of situation. So those two have just been removed from the reported. Systems just don't report on those type of things as they're really not common or used in the exterior environment. And lastly, I just want to point out, for the NLC version 4, which is pretty much everything that's currently listed, we have our SmartCast technology products. You can see a ZR and a stylus here, as well as the Odyssey wireless control system, which is more of components based and not integrated into the Luminaire. So a little bit more flexibility in certain situations there. And then we have some partners, Synapse, or what we use is their Simply Snap devices, with some of our exterior situations or high bay situations. So these are all listed on the current QPL and available to go check out. Thank you.
All right, so we'll transition to questions, and just to remind the audience that please use the chat box or the Q&A box to submit your questions. And while we're waiting on that, John, just to kind of finish up what you had mentioned, we also do a little bit with Lutron, so they can also be found on the QPL if that's people's preference. Can you talk about, because we ended with a version 4, and this presentation is really about version 5, can you talk about how we'll be transitioning to version 5 as an industry, what that timeline looks like?
Yeah, it's roughly over the next year and a half. So products that are listed for version 4, I think, go through something like April of 20. Let's see, we're in 2020, so 2021. So quite a bit of time before that would actually anything that's version 4 would kind of, I guess, be removed. But basically, version 5, that requirement for cybersecurity takes a little time to implement. So they're expecting that we will, it'll take a little bit longer for most systems to come up to version 5 due to that certificate, that independent review of your cybersecurity.
And then I don't know if you mentioned it, how often are these versions updated? Is it a time cadence as to what we can expect in terms of version updates?
Yeah, so currently the DLC is updating the NLC every year in roughly June. So that has been the cadence for the last 5 years, obviously. I'm hoping it actually does start slowing down a little bit. It was every year due to just the ever-changing requirements or the evolving network lighting control environment. I think the required and reported feature sets that they currently have are getting a little bit more stable. I think over the next couple of years, they're really going to be focused on interoperability is what they're projecting. So there may be some movement there, but for the most part, the required and reported capabilities are kind of set.
And this is similar to the QPL, I'm imagining, where stakeholders like Cree Lighting can offer input, but in the end, the utilities are kind of driving the ultimate direction that this goes. Is that a true statement?
Yeah, in general, the DLC is a utility-run organization, or utility member organization, I should say, run by the Energy Efficiency Forward out of Massachusetts. And we, as industry partners, certainly contribute to the technical requirements and comment as they get developed. But in the end, it's driven by those two, the utilities and the DLC themselves.
Yeah, I think people that are familiar with kind of like our core SmartCast, what we might call our entry-level SmartCast system, understand that it doesn't necessarily deliver the way we, implement SmartCast in many applications, all the required functionality. Can you talk about that, or just make that distinction between the requirements versus maybe what's on the QPL versus what actually gets implemented?
Yeah, so it's good to note that all the systems that are listed are capable of, they have devices or they have system setups that will meet the required and the, what they might report on as well, the required capabilities being the most important. It doesn't mean that every time you implement that system that all those features are actually there. So if you're an interior environment where daylight harvesting, or it doesn't matter, maybe a system is out there that functionality doesn't have to be deployed, or um, obviously plug load is not a required item, but might be deployed in California, but not other spaces. So each deployment is really unique to its application and doesn't necessarily have to have everything installed. You might not have dimmers involved. You might not have, other sensors that might not be important for your application, even though they provide that required functionality for the DLC. Your implementation does not have to necessarily conform to some required set of features.
Yeah, and I think everybody that's kind of interested in listening to this topic as lighting consultants in one way or another, whether you're a salesperson or not, you're kind of consulting with your customers. You and I, John, have talked about scheduling on the indoor space versus occupancy detection. Do you want about scheduling on the indoor space is not required, it's reported, but maybe just your feeling in terms of occupancy versus scheduling?
Yeah, I think for exterior it makes sense due to some of the astronomical impact of scheduling. I think scheduling on the interior is not required, and mainly because your daylight harvesting, your occupancy sensing, those type of features, task tuning, all those things combined, really schedules could override them a little bit. By setting a schedule might have more detail than it needs to, where if you really just look at the environment and power the lights appropriately as the environment is presenting to the sensors, I think that's going to give you the most energy savings and functionality versus implementing a schedule that actually might end up wasting more energy than or effort around the control system than just really deploying really what I believe is the best is a luminaire level control, where you have all those sensors available and a lot of flexibility and zoning available that provide, with occupancy sensing, really overrides anything you could do with scheduling.
Yeah, I just think about our current world too, which nobody could predict. But if you think about today, if you're a school that's running a schedule and there's no kids and haven't been, kids in classrooms or teachers in classrooms, or even in the corporate world in which we live in, with a lot of us, working remotely now, and the office of the campus looks a lot different in terms of the amount of activity. There's certainly a lot of waste that could be associated with that. And I think in the outdoor space, the other thing that is a little bit more challenging is ox sensing and reliably being able to manage a larger space with pole spacing as it might be, or indoor spaces. It seems like we can do that a lot more effectively.
Yeah, I would agree with that. Absolutely.
All right, John. Well, I'm not seeing any other questions. If you want to advance, we will wrap up.
Okay.
I do want to thank John again for his time and doing a really great job of condensing this topic. I do want to let the audience know that there is an AI version of this presentation that is available for 1LU/HSW. So if you're interested in that, reach out to your sales contact, or you can send me a note, and we can work on trying to get something scheduled that could be done in person or in the current world virtually. So again, if that's something of interest, let me know. I also do want to thank the audience. I want to thank you guys again for joining us. And as we look forward to next week, we're going to look at understanding driver technology. So we'll talk a little bit about driver technology, including dolly drivers. And in the following week, we will talk about mid and high-powered LEDs and should we care in terms of what are being implemented in some of the product designs. So with that, again, thanks everybody for joining us, and everybody have a great weekend. Take care.